Probabilistic AI and Bayesian reasoning, rethinking confidence under uncertainty. In the fast-evolving world of artificial intelligence, it's easy to get swept up by the astonishing capabilities of modern systems. From chatbots that mimic human conversation to models that forecast sales or automate diagnoses, traditional machine learning has earned its reputation for impressive predictive power. But beneath the surface lies a critical limitation. Most of these models produce only single-point predictions. They tell you what is most likely to happen, but offer no insight into how uncertain they are about that outcome. For example, a model might say, sales next quarter will be 10 million without revealing whether that estimate is rock solid or based on shaky ground. In a world where data is noisy, incomplete, or rapidly changing, this overconfidence can be dangerous, especially when decisions carry real-world consequences. This is where probabilistic AI enters the picture. Probabilistic AI, or PAI, is designed to handle uncertainty head-on. Rather than issuing firm black-and-white predictions, PAI provides a range of outcomes, along with the probabilities of each. Built on the foundation of Bayesian modeling, it treats knowledge as something that should be updated as new data arrives. At the heart of this approach is Bayes' theorem, a statistical principle that lets models update their beliefs based on observed evidence. In practice, this means that probabilistic models don't just answer questions. They explain how sure they are, how they arrived at the answer, and what assumptions they're making along the way. This makes them especially powerful in complex or uncertain environments. By doing so, probabilistic AI directly addresses some of the most glaring weaknesses in traditional systems. One particularly persistent issue in today's AI landscape is hallucination. When models, particularly large language models, LLMs, generate convincing but incorrect outputs, these errors are often delivered with total confidence, making it hard for users to know when they're being misled. Probabilistic AI offers a powerful remedy. It surfaces uncertainty rather than masking it. If a model doesn't know the answer, it can say so. Instead of confidently giving you a wrong number, it might say, there's an 85% chance it's between X and Y, but I'm not sure. This makes room for smarter human-AI collaboration. When models express doubt, users can choose to act, collect more data, or reroute decisions. It transforms the AI from a blind oracle into a partner in decision-making. Beyond better uncertainty handling, probabilistic models offer another significant edge: interpretability. Traditional deep learning systems are often criticized as black boxes. They produce outputs, but it's not clear how or why. In contrast, Bayesian models are built around explicit assumptions. They make their internal logic visible through structures like causal graphs or directed acyclic graphs, DAGs, which map out the relationships between variables. This transparency is crucial in fields like medicine or finance, where trust and traceability are non-negotiable. On top of that, PAI naturally encourages better data collection strategies. It can tell you where it's uncertain and guide you to the most valuable next piece of information. It also tends to be more robust to overfitting because it doesn't just memorize data. It models the uncertainty around patterns and anomalies. It's important to note that while all LLMs are technically probabilistic, since they generate outputs by sampling from probability distributions over tokens, this doesn't make them probabilistic AI in the Bayesian sense. These models calculate what word is likely to come next based on patterns in their training data, but they don't maintain uncertainty over beliefs or hypotheses. However, some emerging models are beginning to bridge that gap. Google DeepMind is actively researching and applying elements of Bayesian probabilistic reasoning in specific areas, such as scientific applications and tool use within their AI models. These models can better calibrate their confidence and adapt based on the complexity of the task. Newer Google Gemini models are described as thinking models that emphasize internal reasoning before generating responses. This focus on a reasoning-first approach could potentially involve probabilistic methods for evaluating different possibilities. Anthropic's Claude models are also pushing toward uncertainty-aware systems, experimenting with self-critique and calibration. Microsoft Research has conducted work on Bayesian approaches to machine learning, including research on measure transformer semantics for Bayesian machine learning. Their research integrates probabilistic techniques into model architecture itself and exploring the use of probabilistic programming languages like Pyro and NumPyro to give models deeper reasoning capabilities. While mainstream LLMs don't yet fully operate under Bayesian paradigms, these hybrid approaches are laying the groundwork for more trustworthy, transparent AI. The promise of probabilistic AI isn't limited to research labs. It's already reshaping industries. In finance, for instance, probabilistic models help forecast market behavior with a clear understanding of risk, guiding investment strategies that weigh not just potential gains, but possible losses. In healthcare, they support clinical decisions by offering probability ranges for diagnoses or treatment outcomes, helping doctors balance risks and benefits. Supply chain systems use probabilistic forecasting to plan for a range of demand scenarios rather than a fixed prediction, minimizing shortages or overstock. In autonomous systems, from self-driving cars to delivery drones, PAI provides real-time risk assessments that improve safety and adaptability in uncertain environments. Even in areas like climate science and policymaking, probabilistic models are helping leaders understand the consequences of different scenarios, fostering more informed decisions in the face of complexity. In conclusion, probabilistic AI offers a vital evolution in the way we build and interact with intelligent systems. It acknowledges the reality that our data are imperfect and our understanding incomplete, and it builds that awareness into the core of the model itself. By surfacing uncertainty, encouraging transparency, and offering interpretable reasoning, PAI doesn't just improve accuracy, it builds trust. As AI becomes more deeply embedded in decisions that affect lives, resources, and rights. This shift from confident guesses to calibrated insights may be one of the most important upgrades we make. I'd love to hear your thoughts on this topic. Are you working with probabilistic models or curious to try them out? Have you seen examples of uncertainty-aware AI in your own industry? Please drop a comment below. And if you found this information helpful, please like, share, and subscribe to stay tuned for more deep dives into the future of intelligent systems. Thanks for watching. Mahalo.